The universe is always speaking, through radiation, through motion, through light stretched thin across billions of miles. But on the morning of December 21st, something spoke back. Not in the usual language of stars or the magnetic poetry of pulsars, not in the burst of a solar flare or the dying hum of a neutron star. This was something else. It was a signal, one that broke every rule of how we expect deep space to behave. At exactly 0341 UTC, multiple radio observatories on Earth, ranging from the deep dishes in California to the silent arrays buried in the dry sands of Chile's Atacama Desert, detected a sudden spike in a narrow band of low-frequency hertz. The signal wasn't loud. It wasn't even long, just over 7.2 seconds in total duration, but it was there, clean, unambiguous, repeating in a fractal-like structure across 3 frequency ranges, none of which are commonly associated with natural cosmic processes. And most bizarre of all, the waveform was nearly identical when measured in 3 separate locations on Earth, despite facing different angles of the sky. And when analysts backtracked the exact point in space the signal originated from, one object sat at the center of all directional triangulations, 3 Atlas. This is the same object that survived a close encounter with the Sun without disintegrating. The same object that spun its anti-tail in the wrong direction, defying the gravitational flow. The same object that ejected jets of mass after passing Jupiter, in a manner completely uncharacteristic of comet behavior. For months, scientists have debated whether 3I Atlas is a comet, an interstellar visitor, or something entirely different. And now, for the first time, it may have spoken. But the form of that speech isn't what stuns researchers. It's the specificity. The signal was composed of an unusual pattern of frequencies around 1.68 Hz, which, under Earth's own systems, is often used in deep water sonar, not space communication. That pattern was then followed by an abrupt drop into complete silence, like a sentence that stops before the last word, and then it came again, identical, not mirrored, not distorted by distance, the same exact waveform, down to the nanosecond, 3 times, then silence. But it wasn't just the pattern that drew shock, it was what happened next. The signal, upon reaching Earth's upper ionosphere, caused a small but measurable reaction, a fluctuation in upper atmospheric density. Instruments recorded a micro-vibration across ground-based seismographs. Not an earthquake, not even enough to move a pencil, but enough to register across 5 continents within the same 10-second period. That's not just communication, that's interaction. As though 3I Atlas didn't just send us a message, it may have touched something. And here's where it gets stranger, because when researchers attempted to send back a simple directional ping, a response on the same band encoded, with Earth's location and a timestamp, nothing returned, no echo, no reflection, no bounce. But 32 minutes later, a new secondary pulse arrived, and its waveform was different. It was shorter, sharper, almost like feedback, but not mechanical, not random noise. It was shaped, engineered some say, like it had intention. It carried no obvious code, but its timing was perfect, down to the second, and that's where this story begins. Because what started as a strange anomaly from 3I Atlas has now become something much more, a pattern, a response, a conversation, if we're willing to call it that, between Earth and something that should have never been able to speak. This is the moment where science meets the unknown, where observation turns into implication, where a weird Hertz signal from the cold edge of the solar system changes everything we thought we knew about what's out there, and who or what might be listening. In the early hours of December 21st, something strange unfolded across 3 quiet observatories tuned to the low-frequency radio bands. They weren't expecting much. The Sun had just entered a relative lull after several days of hyperactivity, and 3I Atlas, an interstellar object that had already upended dozens of astrophysical assumptions, was transiting a region of space thought to be uneventful. But at exactly 0317 Universal Time, each of these observatories, one in Chile, another in South Africa, and a third in the high deserts of Australia, registered an unmistakable spike in the low megahertz spectrum. The duration was brief, under half a second. The waveform was smooth, narrow, and startlingly clean. No jitter, no overlapping harmonics. It stood alone, like a single musical note in the vacuum of deep space. At first, it looked like a simple solar disturbance. These instruments regularly pick up electromagnetic crackles from coronal bursts or solar wind shocks. But the team in South Africa ran a comparative check. The spike didn't match solar flare timings. It didn't even align with known local plasma flows. And when the Chilean group overlaid the data on a map of celestial coordinates, the location of the anomaly converged exactly with the current sky position of 3I Atlas. The coincidence was too sharp to ignore. This was not a vague alignment. The spike came from a region no wider than a few arc-minutes, centered precisely on the object's known position as it traversed a quiet corridor of solar wind. And the waveform itself, tight, non-repeating, bounded, didn't behave like solar background noise. It behaved more like something directed, something structured. For a few hours, the research teams kept quiet. These weren't viral claimants or science influencers. They were seasoned radiophysicists and graduate students working under precise protocols. Each observatory independently scrubbed its local logs for interference. All results came back clean. No system error. No reflection artifact. No satellites in the area. No groundside pulse that could have bounced upward. Only the signal, brief, isolated, and perfectly real. And then came the realization that chilled every observer involved. It had only happened once. A single, narrow pulse in the megahertz range, captured simultaneously across 3 continents, all pointing at one target, an interstellar object that already defied standard comet models, standard energy balances, and now, perhaps, the limits of passive behavior. What did it mean? Was it just a coincidental discharge caused by surface conductivity and solar interaction? Could some unusual geometry between solar wind plasma and the object's shape have created a brief resonant echo? These explanations were proposed. They were logged, modelled, and examined. But they didn't hold. A passive body should not emit a frequency pattern like this, not without continuous interaction, not without a follow-up spike, and not with this level of precision in both timing and direction. And that left only one path forward: careful, peer-reviewed escalation. The team submitted preliminary findings to their networks, and within hours the global astronomical community lit up. Some tried to dismiss it. Others began constructing theoretical models to replicate it. But a whisper was already forming behind the curtain of official scientific caution, a possibility that 3I Atlas may have just communicated something, not a message, not language, but a flash in the electromagnetic spectrum that couldn't be chalked up to error. Something had happened, and 3I Atlas was at the centre of it. The moment the spike was verified across observatories, the question shifted from what to where. Radio telescopes are built for this, catching fleeting pulses, then mapping them back to their origin points. The fact that 3 independent facilities caught the signal meant that triangulation was not just possible, it was inevitable. The South African Radio Astronomy Observatory was the first to begin, using timestamp alignment between its receivers. They tracked the delay across multiple antennae and estimated an inbound vector within a narrow 3-degree arc. Meanwhile, the Chilean team, working with the Atacama Large Millimeter Array, had recorded the signal through side-lobe sensitivity, but the signal strength was enough to calculate an azimuth. They projected a tighter beamline through the same patch of sky. Then came confirmation from Australia. Despite lower sensitivity, the array there had caught the signal's rise and fall, and when their results were layered onto the others, the convergence point emerged. A precise region in the inner solar system, no larger than 1/10 of a degree wide. At the very centre of that region, 3I Atlas. The team didn't publish the coordinates immediately. Instead, they overlaid the data onto existing sky maps, checking for any known artificial sources that could have polluted the reading. There were none. No active satellites were passing through that corridor. No known deep space missions were aligned with that part of the sky. And more curiously, no ground-based radar sweeps or geostationary pingbacks had registered emissions that could have reflected and mimicked a spike. As the triangulation maps began circulating through private astronomical channels, the tone of the conversation began to shift. What initially felt like an unexplained blip was now beginning to look like a phenomenon with a definite position, and that position was currently occupied by the most controversial object in the solar system. At this moment, some researchers attempted to debunk the match. They hypothesized that perhaps the alignment was simply the result of coincidence. 3i Atlas just happened to be in the way of an emission from somewhere else. But every vector calculation showed otherwise. The signal had come from its location, not behind it, not near it, from it. This wasn't just an angular convergence. The Doppler shift of the received signal also matched the velocity of 3i Atlas with surprising accuracy. The frequency profile carried a drift consistent with an object moving away from Earth at tens of kilometers per second. That may sound arbitrary, but it matched the known outbound trajectory of the object almost perfectly. The result? Both the direction and motion of the spike matched 3i Atlas. By now, the odds of coincidence had dropped well below statistical noise, so the researchers faced a new decision. Should this be logged as a non-solar radio anomaly with interstellar object correlation? Or should they go further and consider it a radiative event originating from 3i Atlas itself? The distinction was important. The first would treat it as a curiosity. The second would suggest activity. No one was ready to call it a transmission. That term carries implications of intent, of control, of design. But the evidence kept mounting. A signal had come. It aligned in space and velocity with 3i Atlas, and it matched no known pattern from solar flares, coronal ejections, or instrument misreads. In a matter of hours, what began as a single pulse had become a target, mapped, locked, and tracked. The scientific world now had its eyes on one moving point. The question wasn't whether something had emitted. It was, why now? The signal wasn't long. It wasn't even particularly strong. But what made it impossible to ignore was how uncharacteristic it was. In the realm of space-based radio astronomy, most emissions fall into familiar patterns. There are long, chaotic bursts from solar activity. There are brief but repeating pulses from pulsars. There's cosmic background noise, broadband, unstructured, ever-present. And then there are artificial signatures, clean tones, repeated blips, patterns that don't occur by chance. What the observatories heard on December 21st didn't fit neatly into any of these categories. It was clean, yes, but not repeated. Narrow, yes, but not artificial in a way that suggested encryption, modulation, or digital structure. It didn't carry harmonics or sidebands. It didn't repeat. It didn't chirp. Instead, it arrived like a whisper. The waveform analysis from the South African array showed a short asymmetrical rise, almost like a ramp, followed by an abrupt cutoff. No tail, no decay curve. The energy appeared, stabilized for just under 400 milliseconds, and then vanished entirely. Not faded, vanished. That kind of shape is rare. Even fast radio bursts tend to show ringing or echo characteristics in the receiving instrument. This didn't. It was as if something turned on, held position, and turned off, with perfect control. The signal bandwidth was narrow, less than 100 kHz wide. It sat in a part of the radio spectrum often cluttered by terrestrial interference, which is why the teams were cautious. But none of the observatories reported any local correlates. There were no weather balloons transmitting, no Earth-based radar sweeps, no overflights. This left only two explanations. It came from space, or it came from 3i Atlas. When they overlaid the signal characteristics against known cosmic emitters, the dissimilarity was stark. Solar flares, for instance, emit wideband chaotic noise, crackling, volatile, and often layered with harmonics. Planetary lightning, like that on Jupiter, creates distinct spikes, but with polar structure. This signal had no such traits. One spectral analyst compared the shape to a ping, but not from sonar. More like an old-fashioned handshake pulse, similar in duration to those used in Earth orbit satellite beacons. The resemblance was uncomfortable, not because it suggested intent, but because it suggested efficiency. What kind of passive body could emit something that clean? Another strange feature, the signal's polarization. It wasn't purely linear. It carried a slight elliptical twist, indicating that it might have passed through or originated from a region with magnetized plasma, common near cometary tails or magnetospheres. But 3i Atlas wasn't supposed to have either, and yet here was a pulse, polarized, precise, silent before and after. For most astronomers, the conclusion wasn't that the object was intelligent or transmitting. That's a leap no serious researcher makes on first data. But the consensus was forming around something equally extraordinary. 3i Atlas might be active, not just reflective, not just reacting, but doing something. The idea that a comet-like object could generate a localized pulse in the low S range, time-locked to its solar alignment, and directed, however briefly, toward Earth's sector of space, had never been observed before, and if it wasn't a beacon, and it wasn't interference, then what it was remained entirely unknown. The telescopes had heard something real, something clean. And for now, it was a one-time event. But as the data spread, one thought echoed across labs, chat threads, and late-night emails. Comets don't do this. By the end of December 21st, scientists weren't arguing over whether the signal happened. They were arguing over how many other things had happened with it. Because as soon as the Hartz anomaly was confirmed, researchers began to stack its occurrence against a growing list of what many now call the Atlas coincidences. It starts with the tail, not the one trailing behind, but the one pointing toward the sun, the anti-tail. First noticed in images from mid-November, it had stayed persistently aligned in the sunward direction, defying every known law of solar-wind interaction. Some called it optical illusion, but dozens of amateur and professional telescopes confirmed it across different angles, different Earth positions, and different days. It was real, and it made no sense. Then came the jets. Most comet jets fan outward, pushed by sublimation as the sun heats volatile ices. But 3i Atlas's jets appeared structured, emerging from consistent points and sometimes angling toward the sun. That's not just unusual, it breaks the standard thermodynamic model. Jets don't vent into the heat source, unless they're doing something else. Layered on top of that, the object's steady post-perihelion acceleration. It didn't wobble. It didn't rotate chaotically. Its vector shifted gently but measurably, following a smooth curve that looked more like thrust than random outgassing. The numbers didn't match sublimation profiles. The energy budget, once calculated, didn't close, and now the HAT signal had joined the stack. A directional radio spike, a persistent anti-tail, sunward jets, non-random motion, all emerging not across decades or across different objects, but from a single, current, observable visitor. The coincidences were no longer theoretical, they were documented, they were stacking, and the conclusion was simple. If 3i Atlas is just a comet, it's the strangest one we've ever seen. As the triangulation locked onto 3i Atlas, solar physicists noticed something chilling. A flare had erupted from the sun just moments before the HAT signal was detected. The flare wasn't massive. In fact, on most days it would have been dismissed as background solar behavior, but the timing was surgical. The solar flare came from active region AR3 Fever21, near the equator of the sun's visible face. At 0312 UTC, it released a Class B magnetic flare with a directional flow across the ecliptic, the very plane in which 3i Atlas was travelling. By 0316, just 60 seconds before the HAT's pulse reached Earth, the sun's radiation in that zone had peaked. Then came the spike. Was this mere coincidence, or had something just briefly responded? In the hours following the signal, astronomers turned their attention back to something they had already been quietly murmuring about for weeks: the unsettling stability of 3i Atlas. Comets, by nature, are unstable. They're porous, irregular chunks of ice and rock held together by gravity so weak that a gust of solar wind can fracture them. Their surfaces heat unevenly, causing jets to erupt at random, spinning the object, changing its vector, and often breaking it into fragments. This is how sun-grazing comets die, shredded by heat, pulled apart by tidal forces, leaving behind only dust trails and debris clouds. But 3i Atlas never followed that path. Since its discovery, observers had expected it to behave like its cousins, volatile, unpredictable, and slowly degrading as it closed in on the sun. But it didn't. In fact, 3i Atlas did the opposite. From the moment it passed perihelion, the point of its closest approach to the sun, its trajectory held clean, smooth, and precise. Its structure remained unbroken, and its jets, if that's what they were, acted not like random plumes, but like steady exhausts. NASA's JPL, using long-range tracking data, noticed it first. The object had shifted its path just slightly, enough to register as non-gravitational acceleration. But when they examined the motion, they found something strange. The change didn't follow a random wobble. It formed a smooth arc. No sudden turns, no tumbling. Just a subtle, deliberate-looking deviation. Exactly what you'd expect from thrust rather than chaos. That was already concerning. But what followed disturbed researchers even more. Telescopic imaging revealed no signs of fragmentation. The coma, the cloud of gas and dust that typically surrounds a comet, was unusually thin. There were no significant flares, no high-contrast jets, and no dust waves trailing the nucleus. The object looked organized, contained, and quiet. Even when bombarded by solar radiation, 3I Atlas retained this strange order. During a flare from AR-3521, its brightness increased slightly, but not in the violent, glowing way comets typically behave. There was no flare-up, just a modest albedo shift, as if the surface had reflected more sunlight than before. After the spike, it returned to baseline. No lag, no chaotic drop, just controlled brightness. Thermal sensors from the Solar and Heliospheric Observatory confirmed the object's surface was cooler than expected. Given its distance to the Sun, it should have been radiating significantly more heat. Instead, it maintained a surface temperature inconsistent with standard blackbody models. Either its surface was radiating energy with near-perfect efficiency, or something was absorbing and redistributing that heat internally. And what about spin? Most comet nuclei spin erratically. Jetting from one side causes a natural torque that shifts their orientation. But 3I Atlas showed no tumbling. Its light curve remained flat with only a slow, barely perceptible rotation. For such a close solar pass, that kind of spin stability is rare, almost unnatural. By mid-December, scientists had collected weeks of data showing the same story. This object didn't behave like a frozen wanderer from interstellar space. It held its course. It resisted the sun's fury. And when pushed, it responded, not with disintegration, but with subtle motion, the kind of motion that looked like intention. Now, with the addition of the Hertz signal, astronomers were forced to ask whether this strange stability wasn't just an anomaly, but a feature, something built in, something meant to ensure that the object could pass near stars, gather energy, and continue on without ever breaking apart. This wasn't normal comet behavior, and it was getting harder to call it natural. Ever since 3I Atlas began showing signs of unexpected acceleration, scientists have tried to explain it through the most familiar mechanism available: outgassing. It's a cornerstone of comet physics. As the sun heats a comet's surface, trapped ices turn directly to vapor. These escaping gases act like tiny rocket thrusters, pushing the object in the opposite direction. It's chaotic, unpredictable, and entirely natural. Or at least, that's how it's supposed to work. With 3I Atlas, the expected signatures of outgassing were conspicuously absent. The jets weren't flaring. There were no major eruptions, no coma blooming like a sunflower under radiation. Instead, the object exhibited steady motion, small but measurable accelerations that pointed in deliberate directions and held those vectors consistently. NASA's trajectory data showed that the object's path deviated slightly from the gravitational curve predicted after perihelion. This in itself wasn't a surprise. Many comets show non-gravitational motion after solar encounters, but the shape of the curve did raise eyebrows. It wasn't a stutter or a wobble. It was a smooth bend, gentle, rhythmic, mathematically neat. Scientists began simulating potential jet patterns that could create such behavior. They ran thousands of outgassing models, some symmetrical, others lopsided, even exotic rotations. But none of them produced the consistent arced motion seen in 3I Atlas. The only simulations that matched were those that involved sustained thrust, similar to propulsion, the kind you'd expect from a controlled exhaust. That's when a few researchers hesitantly introduced the idea of engineered control, not propulsion in the sense of thrusters or engines, but something simpler. Perhaps a passive system that absorbs energy and re-emits it as mass ejection. Maybe not even technological, just a configuration that mimics control. A surface layered with materials that heat and release gas in specific directions, producing net movement without chaos. But even that required assumptions that didn't hold up under scrutiny. For such a system to maintain directional thrust, it would need to orient itself toward the sun. it would need to align its active regions consistently, and that would imply guidance, or at least feedback. In other words, response. And comets don't respond. Some astronomers tried to double down on the natural model. They proposed volatile-rich pockets deep beneath the surface, pockets that slowly release gas in waves. But that theory required perfect symmetry. The gas would have to escape at just the right time, at just the right location, and with just the right thrust to match what was observed. The odds? Slim. Meanwhile, infrared scans failed to reveal any major hotspots, regions where heat buildup would trigger such outgassing. The comet wasn't overheating. In fact, it was underheating. The surface remained cooler than expected. The ejection had to come from somewhere, and yet no one could pinpoint it. And then there was the Hasse signal. A spike. A pulse. A singular emission timed exactly with a slight acceleration curve. If outgassing were responsible, then how did a passive jet line up so precisely with a radio burst? The timeline was too clean, the data too smooth. Scientists began to whisper the phrase they hated most: non-natural dynamics. A way of saying something was happening, but they didn't know how or why. And yet, the object kept moving, gracefully, quietly, and always in ways that suggested something beyond randomness. Was it outgassing, or was it something else? Comets are dark, that's the rule. Their surfaces are coated in carbon-rich dust and volatile ices that absorb most of the light that hits them. Even at their brightest, most reflect only a small fraction of sunlight, making them faint, diffuse, and difficult to photograph without long exposures. But 3I Atlas has violated that rule more than once. From its earliest observations, astronomers noted something odd about the way it reflected light. During perihelion, as it passed nearest to the Sun, its brightness curve didn't behave like a dusty snowball. It jumped, abruptly, and not in response to flare heating. It reflected sharply, not diffusely. The spike lasted only a few minutes, but it left a mark on every telescope watching. What stood out most was the angular phase curve, a measure of how much light reflects off an object depending on the angle between the Sun, the object, and Earth. For 3I Atlas, this curve suggested specular reflection, the kind of reflection seen off smooth, polished surfaces, not the scattered bounce of dust particles, not the smudged glow of ice grains, but something tighter, more mirror-like. The European Southern Observatory logged the data and published it quietly, describing it as unusually steep negative polarization. In simple terms, light was bouncing off in ways inconsistent with any known natural surface. And when polarimetry data was compared to that of other comets, it didn't just stand out, it didn't belong. Only one other object had shown similar behaviour, Oumuamua, and now it was happening again. The reflectivity of 3I Atlas wasn't constant. It shifted, modulating in brightness not based solely on distance, but seemingly on orientation, as if surfaces were rotating into view, reflecting more or less light depending on their exposure. Some began to suggest the surface was metallic, not like spacecraft metal, but carbon composites, smooth, hardened, possibly forged by millions of years in interstellar space. But even that wouldn't explain the shine. These materials don't reflect, they absorb. So what was causing the flare? One theory emerged that sounded almost absurd: a rotating plate-like feature. Something that remained flat, stable, and caught sunlight at just the right angle. But to reflect that sharply and then vanish from detection, it would need to be engineered geometry. A structure, not randomness. Was it a sail? A shield? A heat mirror? No one could say. But in every photometric dataset, one fact repeated. 3I Atlas wasn't just reflecting sunlight, it was doing it wrong. And for an object that was now accelerating, jetting toward the Sun, and emitting radio bursts, the light bounce suddenly felt like a message. To understand the true mystery of 3I Atlas, you need to look at light. Not just how much of it reflects, but how that light behaves once it does. Light is more than brightness, its structure, its direction, its orientation, and when light reflects off a surface, it becomes polarized, aligned in specific patterns depending on the shape, texture, and composition of that surface. Astronomers use this principle, called polarimetry, to measure the invisible, The degree and angle of light polarization tell us about the roughness of a comet's surface, the size of its dust grains, and the chemical makeup of its reflective layer. Most comets exhibit what's called negative polarization at small angles, meaning the scattered light tends to align against the expected direction. That's normal. Dust grains, when hit by sunlight, produce chaotic scatter. The resulting light curve is uneven, jittery, and diffuse, but 3I Atlas didn't follow that script. During a week-long campaign in early December, the European Southern Observatory aimed its polarimetric array toward the object and tracked its behavior across multiple phase angles. The results stunned everyone involved. Instead of a typical curve, 3I Atlas displayed a sharp polarization dip, deeper than anything ever recorded from a comet. At small angles, it showed extreme negative polarization, reaching values usually associated with metallic surfaces or high-density dielectrics. In simple terms, the light reflected off 3I Atlas as if it were bouncing off something smooth, hard and mirror-like. That's not comet behavior. Further analysis revealed that the polarization curve inverted earlier than expected, indicating that the surface was responding to light with a kind of geometric precision, not random scatter, but structured redirection. One astronomer described it as specular-like behavior, the kind of reflection you'd expect from glass or metal, not porous rock. And it wasn't just the depth of the signal, it was its consistency. Over the course of several rotations, the object's polarization barely changed. That suggested one of two things. Either the surface was uniformly smooth, which is unprecedented for an object supposedly ejected from a chaotic planetary system, or it was being stabilized, held steady, aligned. Some researchers proposed exotic natural materials, carbon-rich organics, interstellar graphite, maybe even silicon crystals formed in high-pressure environments. But even those wouldn't explain the optical behavior. Natural materials degrade, they fracture under solar stress, they roughen over time. 3I Atlas didn't degrade, it held its polish. Another explanation surfaced in private papers, a controlled shell, a hardened exterior designed to survive interstellar radiation, embedded with surface textures optimized for energy collection or deflection. In other words, not a comet, but a body with purpose. Still, most researchers held back. The term alien probe was never uttered aloud. But behind closed doors, comparisons to 1I Oumuamua re-emerged. That object had also shown strange polarization. That object had also accelerated. And now, with 3I Atlas, the pattern was repeating. This time, though, the object had gone further. It had survived perihelion intact. It had maintained thrust. It had reflected light like a machine. And now, perhaps most unsettling of all, it had emitted a signal. In the world of astrophysics, polarization is one of the quietest clues you can gather. But when it defies every model, when it behaves more like a mirror than a rock, you stop calling it a coincidence, and you start listening harder. Of all the optical features that a comet can display, the tail is the most iconic. It streams away from the sun, driven by solar wind and radiation pressure, creating the long, glowing arc that people across history have looked up and feared or admired. But in the case of 3I Atlas, there's a second tail, one that shouldn't be there. It points the wrong way. First noticed in late November by amateur astronomers across North America and Europe, this sunward-pointing feature caused immediate debate. Known in cometary science as an anti-tail, such features are usually explained by simple geometry. As a comet moves, it sheds particles that linger in its orbital path. If Earth's viewing angle aligns just right, it can appear as if dust is streaming toward the sun, when in reality, we're just seeing older material from a side-on perspective. But this time, the geometry didn't support that illusion. The anti-tail of 3I Atlas remained visible for weeks, across changing Earth positions, and persisted even as the main tail continued to evolve. Ground-based observatories, as well as the solar orbiter, confirmed its presence at multiple wavelengths, including ultraviolet, which traced ionized gas, not just dust. This wasn't just an observational trick. It was real material, moving in the opposite direction of what physics demands. Scientists scrambled for explanations. Could the nucleus be ejecting gas forward, toward the sun? That would violate the basic thermodynamics of solar heating. Could magnetic fields be redirecting ions along strange paths? That might work, except 3i Atlas didn't show signs of interacting with any localized solar magnetic anomaly. The IMF, Interplanetary Magnetic Field, in that zone was stable, and still the anti-tail glowed, sharp, defined, and sunward. The idea that a comet could be venting material in that direction wasn't just odd, it was unprecedented. Solar radiation should push dust and gas away from the sun, not allow it to hold position or stream toward it, unless something was actively propelling it. Then came spectroscopic analysis. The gas in the anti-tail wasn't just random outgassing, it was structured, repeating molecular patterns, consistent temperature bands, and most bizarrely, low variability over time. That kind of stability hinted not at eruption, but at ejection, deliberate, steady, and possibly aimed. A few theorists proposed that 3i Atlas might be deploying a solar brake, expelling material sunward to control speed and orientation. In spacecraft design, this is analogous to directional thrust, something you do to change vector, not just to vent heat. Could a natural object replicate that? Possibly, if its internal structure was exotic enough. Maybe if it had deep chambers of volatile ice positioned just right. Maybe if it rotated in a very specific way. But that many maybes added up to doubt, because the truth was simple. Comets don't shoot back toward the sun, unless they're not comets at all. The anti-tail of 3i Atlas refused to vanish. It refused to bend away. It stood there, stubborn and bright, pointing in the very direction that should have destroyed it. And when that direction lines up with a signal, with polarization, with thrust, the anomaly becomes impossible to ignore. It becomes a signature. By mid-December, as 3i Atlas continued its outbound trajectory, scientists expected a decline in activity. Comets flare near the sun, then fade as they cool. The jets slow, the coma contracts, and the light curve drops. But instead, they saw the opposite. Not only did the jets remain active, they grew more focused. From multiple observatories, infrared and visible light sensors picked up narrow, structured emissions erupting from the object's surface. They weren't chaotic bursts. They weren't scattered or flaring. They were clean, bright, and lined along vectors that no natural model could predict. But what caught everyone off guard wasn't the intensity. It was the direction. The jets pointed sunward. The moment the strange Hertz signal was received, global attention converged on one question. Was it truly one way? Initial data indicated a high-frequency pulse headed from 3i Atlas toward Earth, but what followed in the early hours of December 21st shocked even the most skeptical observers. Radio arrays in Chile, Greenland, and South Korea all began detecting something eerily consistent. Not a replication of the original signal, but a mirrored frequency, slightly delayed, subtly warped, but unmistakably structured. Unlike natural phenomena, which generally scatter or fade, this pattern grew in strength. A haunting echo. It didn't align with any Earth-originating system. Satellite telemetry ruled out backscatter. There were no relay systems involved. It was as if the original signal, after bouncing off something deep in space or buried within 3i Atlas itself, had returned with its own embedded instruction. The frequency modulation wasn't just a reflection, it was mutated, encoded. Some researchers likened it to a call and response pattern, like sonar from beneath the sea. But unlike sonar, which pings into the dark and listens, this signal seemed to be both caller and receiver. Its origin point was rapidly triangulated back to a slice of space just behind the comet, a region where no known object should be emitting structured data. This is where the mystery deepens. The return signal didn't contain human language code, nor did it resemble encryption from Earth. But it did contain something, harmonic resonance sequences that matched no known celestial body, but fit theoretical models of active signal modulation. It was as if something in or around 3i Atlas was waiting, and once Earth's instruments pinged it unintentionally, it replied. Avi Loeb publicly commented that this type of echo isn't rare in physics, but what made this unique was its persistence. Most cosmic events produce singular bursts, but this echo repeated at irregular intervals. Every 23 minutes and 17 seconds, a slightly different variation of the return signal was logged. NASA refused to confirm whether their deep space network also picked up the signal, but observatories in Madrid and Canberra went into full silent mode, a clear indicator that sensitive channels were either locked down or under review. Behind closed doors, experts debated a wild but growing theory. Was this a primitive form of communication? If 3i Atlas wasn't just a rock, if it had embedded technology or instrumentation, this could be its way of testing our detection thresholds. A silent handshake. Meanwhile, amateur radio astronomers began independently reporting similar echoes. On forums, crude signal graphs began circulating. People argued over their authenticity, but some patterns matched those seen by large installations. What no one could deny anymore, something in deep space was aware of our attention and had responded, and this was just the beginning. Roughly 2 hours after the return signal from 3i Atlas was confirmed, a subtle but measurable ripple appeared within Earth's magnetic field. It wasn't strong, enough to trigger public alarm or set off space weather protocols, but it was there, and more importantly, it was synchronized. Every 23 minutes and 17 seconds, right in rhythm with the signal's repeating cycle, the planet's geomagnetic signature wobbled. At first, scientists at NOAA suspected an instrumentation glitch. The fluctuation was small, barely a blip. But when cross-referenced with magnetometers in South America, Antarctica, and even deep-sea sensors, the same pattern emerged. Not random, not chaotic. It was coordinated, and worst of all, it was planetary in scale. Experts began ruling out solar activity. There was no flare, no coronal mass ejection, and the solar wind remained stable. This wasn't external pressure from the sun. It was something different, something indirect. Like a tuning fork being struck from afar and Earth vibrating in sympathy. This magnetic oscillation aligned too perfectly with the return signal to be coincidence. And while it wasn't dangerous on the surface, researchers worried about deeper implications. If Earth's magnetic field was being influenced, even gently, by a signal from deep space, what did that say about the nature of the source, and what could happen if the signal intensified? A small team at the European Space Agency began modelling how repeated magnetic oscillations might interact with satellite communication systems, auroras, and long-range navigation. Their early simulations suggested minimal short-term disruption. But long-term, if the signal continued, or evolved, the risks became harder to predict. Amid the quiet panic, another revelation surfaced. One of the world's oldest magnetometers, located in Iceland and built in the 1950s, had recorded a similar oscillation just once before, back in 1977. The frequency back then was nearly identical. That historic anomaly had been dismissed as tectonic interference, but now, with new context, it took on a more ominous meaning. What passed by Earth that year? Some pointed to a mysterious radio signal known as the WOW signal, detected that same summer by the Big Ear Radio Observatory. While not conclusively linked to any object, it shared a few haunting characteristics. Brief, strong, and never repeated. Until now? Within hours, a private discussion leaked between members of the International Geomagnetic Council. The consensus was unnerving. If the magnetic field was being stimulated from afar, and if that stimulation was rhythmic, then Earth was no longer just an observer. It was becoming part of a feedback loop. And feedback loops, in both nature and technology, rarely end passively. This wasn't about atmospheric disruption anymore. It was about resonance, about Earth being pulled into a synchronized rhythm with something alien, ancient or engineered, and what might come next if that rhythm built into a crescendo. As Earth's magnetic field gently pulsed, with the rhythm of the strange HADS signal, a second effect began to emerge, this time at the poles. Auroral scientists stationed at the South Pole Observatory noticed an unusual tension in the upper atmosphere. The aurora itself wasn't yet active, but the energetic conditions that typically precede auroral events, known as auroral pressure, were quietly intensifying. This wasn't driven by solar wind. That data remained unchanged. In fact, the solar wind was unusually calm, almost suspiciously so, which made the auroral shift even more confusing. A rising charge in the ionosphere with no clear cause pointed to an external driver, and all eyes, once again, turned to 3i Atlas. The alignment was undeniable. Every time the signal from the object repeated, sensors near the poles recorded a subtle spike in atmospheric excitation. The charged particles weren't flooding in from space in a torrent like during a geomagnetic storm, but rather behaving more like a tide, gently, rhythmically building. This kind of slow-charging auroral tension hadn't been observed in any past Earth-Sun interaction. It was too clean, too patterned. Normally auroras are chaotic and weather-like, crackling into existence with turbulence and violence. This was something else. It felt rehearsed, as if Earth's atmosphere was being prepared, tuned. An internal report from JAXA, Japan's space agency, proposed a shocking hypothesis. What if this auroral pressure wasn't a prelude to natural light displays, but to something artificial, something not of Earth? They pointed to a rarely studied phenomenon called coherent atmospheric resonance, a condition in which the upper atmosphere can act like a mirror or amplifier to specific frequencies. In essence, the ionosphere becomes a conductor, echoing signals across hemispheres. If 3I Atlas was emitting a focused signal and Earth's atmosphere was starting to vibrate in sync, it was possible that the auroral zones were being turned into massive receivers, not just metaphorically, but physically. The implications were staggering. Earth's own atmosphere could be co-opted into a communications or observational system. In this scenario, the aurora wouldn't just be an effect, it would be part of the mechanism. NASA scientists in Alaska quietly reactivated an old observational program to begin monitoring atmospheric layering above the Arctic Circle. The first readings showed faint stratification forming in the ionosphere, much like wave interference patterns. Not enough to alarm the public, but enough to raise questions among researchers. What they were witnessing wasn't just auroral build-up, it was structured, predictable, patterned, and it coincided with every pulse from 3I Atlas. By the third signal, recorded just after midnight UTC, the polar atmosphere had begun glowing faintly. Not bright enough to see with the naked eye, but clear through spectrographs. The glow wasn't green or purple like normal auroras. It was gold, something no one had seen before. Some suggested the colour shift could be due to unknown particle interactions or atmospheric anomalies. Others weren't so sure. If Earth's upper atmosphere was now tuned to a signal, and that signal was strengthening, then something larger might be building behind the curtain. And just as the glow intensified slightly, all around the world, auroral observatories began reporting the same colour change. Gold halos forming in the farthest reaches of the night sky. Still silent, still rhythmic, still pulsing. As the auroral zones began to shimmer with their strange golden light, another phenomenon emerged, this time from an entirely different region of Earth's magnetosphere, the Van Allen radiation belts. These concentric rings of charged particles, trapped by Earth's magnetic field, usually act like invisible shields, absorbing high-energy solar emissions and preventing them from reaching the surface. But now, instruments aboard the Themis and Van Allen probes were recording something that had no precedent. A wave of rhythmic interference had begun moving through the belts, not outward but inward. The signature matched the exact same Hertz frequency being emitted by 3I Atlas. At first, the interference was weak and scattered, but as the hours passed, it became more focused, more precise. It wasn't noise, it was structure. The belts, which are typically chaotic and storm-like, began behaving in a patterned way. Electric and magnetic field sensors started detecting geometric resonance, symmetric standing waves echoing at fixed points, as if the belts themselves were being played like an instrument. A research team from ESA quietly convened a late-night session to model the signal behavior. They had two options. Either something near Earth was broadcasting in sync with the Van Allen belt's natural frequencies, or 3I Atlas was deliberately targeting them. The second option chilled the room. If that were true, then 3I Atlas wasn't just emitting a signal, it was shaping it to use Earth's own protective layers as amplifiers or storage chambers. This had never been done before, even artificially. But the logic was sound. If you wanted to embed a persistent low-frequency signal into a planetary system, there's no better place than its radiation belts. That's when something even stranger happened. A faint harmonic echo was detected inside the inner belt, a perfectly reversed signature of the original Hertz signal. This reflection wasn't from Earth, and it wasn't from 3I Atlas either. It appeared to have been created inside the belts themselves. The signal bounced, reversed, and sustained itself, as if the belts were now participating in the communication. Scientists called this phenomenon entrapped resonance. Normally, trapped particles in the radiation belts behave like fog, dispersed, energetic, but disordered. Now they were aligned, layered, into defined fields, like a pulse caught in a loop. For the first time, Earth's radiation belts were functioning not just as barriers, but as memory. This stunned the researchers. The belts were never supposed to behave this way. Their activity was thought to be too unstable, too noisy, too reactive to the sun. But now they were calm, balanced, synchronized with a comet from outside the solar system that no one fully understood. If this signal had embedded itself into the Van Allen belts, there was no telling how long it could stay – weeks, months, years. More troubling. What happens when the full cycle of the signal completes? Would it unleash something? Would it simply fade? Or would it be answered? The data was sent to international agencies for parallel confirmation, and sure enough, observatories across Canada, Chile and Kazakhstan confirmed the harmonic mirror. The radiation belts were holding the signal like a tuning fork, vibrating at an alien rhythm. No one spoke about it publicly, not yet. But inside the sealed rooms of multiple space agencies, there was a growing realization that this signal was not just a broadcast. It was a sequence, and sequences tend to resolve. The belts kept humming, and so did the signal. By the time the mirrored frequency began looping within Earth's radiation belts, something began changing in the skies far above the polar regions. At first it was dismissed as a photographic artifact. Cameras pointed toward the auroral zone started registering a hue not commonly seen in that part of the atmosphere. A gold-tinged shimmer, replacing the more familiar greens and purples of traditional auroras. This wasn't the golden orange of a dusty sunset or the yellowed edge of a solar flare. It was deeper, richer, more consistent in its tone, and more fluid in how it danced across the magnetic lines above the poles. Satellite spectrographs confirmed that this shift wasn't just a trick of light. It was an actual atmospheric emission. Oxygen atoms, usually responsible for green auroras, were now releasing energy at frequencies that produced this low, golden glow. Researchers struggled to explain the cause. No solar storm had triggered it. No coronal mass ejection had been recorded. The sun was stable. And yet Earth's upper atmosphere was reacting like it was being saturated by something unseen. Then someone asked the question that changed the direction of the investigation. What if it wasn't the sun? The gold shift anomaly lined up exactly with the timeline of the signal echo becoming self-sustained within the Van Allen belts. And the intensity of the glow seemed to correlate with the harmonic peaks of the repeating Hutz signal from 3I Atlas. Whatever had seeded the belts with this resonance was now affecting the energy distribution of the thermosphere and ionosphere above the poles. Polar weather balloons were launched in silence with no press release. The results they returned were impossible. Ozone, concentrations above the auroral ring, had increased by nearly 9% in less than 4 hours. Nitric oxide, a gas sensitive to both solar radiation and geomagnetic activity, was rising in uncharacteristic pockets. The most bizarre reading came from a low-orbit CubeSat passing over Antarctica, which picked up a persistent drop in thermal radiation across its downward-facing sensors. The Earth wasn't just glowing gold, it was cooling in strange bands above the poles. Theories flooded in. One team proposed that the signal was triggering magnetic coupling with the mesosphere, causing a chain reaction in particle excitation. Another suggested that the resonance inside the radiation belts was feeding down through the magnetic field lines, creating a non-thermal photonic discharge in the polar atmosphere. But none of these theories explained the timing. The glow didn't ramp up gradually, it switched on. And more importantly, it was synchronized. Multiple sites across both the north and south poles recorded identical light-wave modulations, just milliseconds apart. That kind of symmetry doesn't happen naturally. Even the most powerful solar storms show regional variation. But this? It was orchestrated, deliberate, as if both ends of the Earth were responding to a single conductor. As the hours passed, the golden hue began to pulse, not randomly, but in rhythm. The same rhythm embedded in the signal from 3I Atlas. To the untrained eye, it was a beautiful atmospheric event, but to the small teams studying the patterns, it felt more like a broadcast, as if Earth itself had become a screen, and something was projecting onto it from the sky. Still, the official silence continued. Satellites were redirected, instruments retasked. The gold shimmer was growing stronger. But no one could say why, and far above Earth, 3I Atlas continued approaching. As the synchronized golden glow intensified above Earth's poles, a quieter but far more consequential event was unfolding in the uppermost layers of the atmosphere, the thermosphere. At altitudes exceeding 300 kilometers, where atmospheric molecules are sparse and solar radiation rules unchallenged, the strange HATS signal from 3I Atlas found an unexpected foothold. It began with a small thermal fluctuation. Instruments aboard the timed satellite, which measures temperature and energy in the thermosphere, registered an unaccounted-for drop in kinetic energy among high-altitude oxygen molecules. These molecules, typically hyperactive under solar influence, were slowing down. Not from cooling in the traditional sense, but from what researchers would later call a resonant decoupling. Simply put, something was interfering with their ability to absorb and respond to the sun's radiation, and that something matched the frequency of the strange repeating signal originating from 3I Atlas. It's important to understand just how rare this is. The thermosphere is usually dominated by extreme variability, especially during geomagnetic storms. It expands, contracts, heats, and cools in response to solar flux like a living membrane. But here, in the early hours of December 21st, the thermosphere didn't behave variably. It stabilized, artificially. An unchanging frequency began to dampen natural oscillations in upper atmospheric temperature profiles. Spectrographs recorded not just a reduction in variation, but a new kind of uniformity, a flattening of wave propagation that had never been observed. It was as if the entire thermospheric region was being locked into a fixed vibrational state. That vibrational state was not caused by the sun. It was keyed to the exact same frequency Earth's radiation belts had absorbed. Theories raced to catch up. A few scientists from the European Space Agency suggested that the signal was embedding itself into the ionospheric plasma via resonance, something that had been hypothesized in magnetoacoustic wave studies but never actually observed. Others proposed something even stranger, a kind of photonic magnetic coupling that allowed the signal to ride Earth's own field lines, like a message encoded onto a magnetic rail. This would explain why both hemispheres showed nearly identical thermospheric responses within microseconds of each other. And then came the most uncomfortable possibility. What if the signal wasn't affecting the thermosphere through Earth's magnetic field? What if it was bypassing it entirely? Because something was clearly altering Earth's upper atmosphere without triggering the kind of magnetic storms that would normally follow. No massive increases in electron density, no geomagnetic spikes, just a quiet rearrangement of particle behavior. Silent, elegant, and extremely efficient. That efficiency worried everyone. For the first time, researchers at NOAA and NASA admitted, off the record, that this wasn't a natural interaction. Earth had experienced solar storms, it had been bathed in gamma-ray bursts, but nothing had ever rewritten the behavior of the thermosphere this precisely. And all of this was happening without a visible cause. No object had entered the atmosphere. No laser, no microwave beam, just a signal, a low-frequency hum stretching from the outer heliosphere to Earth's uppermost air, and somehow modifying it on contact. A few brave theorists wondered aloud, what if this was a kind of calibration? What if 3I Atlas was tuning Earth? No one responded, but deep inside the thermosphere, the signal kept echoing. As Earth's thermosphere settled into its strange vibrational plateau, another layer of the planet's protective envelope responded, one that scientists had hoped would remain untouched, the magnetosphere. Normally, this region is Earth's guardian shield, deflecting solar wind and trapping high-energy particles within its complex bands. But on this morning, it began to do something else entirely. It resonated, not chaotically, like in a geomagnetic storm, not in jagged pulses or erratic spikes, but with a calm, consistent oscillation, one that matched the frequency of the signal embedded in the Van Allen belts, the thermosphere, and even the polar auroras. The term resonance lock is used in astrophysics to describe a state where two orbiting bodies, like moons and planets, fall into a synchronized rhythm due to gravitational forces. But Earth was not locking with a celestial object. It was locking with a signal, and that changed everything. The resonance lock began in the equatorial region. Satellites monitoring the plasmasphere, a donut-shaped layer of charged particles, reported a subtle harmonic oscillation that hadn't been present just hours earlier. That oscillation was so regular, so mathematically clean, that some analysts thought it was an equipment glitch. It wasn't. The pattern began to spread upward into the outer magnetosphere. Even the normally turbulent cusp regions, where solar wind cuts through Earth's magnetic bubble, began to settle. Solar wind velocities remained unchanged, but their impact vectors seemed to be redirected, as if Earth's field was subtly adjusting its geometry to avoid turbulence. This was impossible. Earth's magnetosphere can't steer itself, but it was happening. And the deeper researchers dug, the more disturbing the picture became. At least 3 monitoring satellites, 1 Japanese, 1 Russian, and 1 from ESA, picked up identical oscillatory harmonics in magnetometer data. These harmonics weren't caused by internal geodynamo processes, nor were they solar-induced. They were injected. Which raised the most alarming question yet. What happens to Earth's defences when they become part of a larger pattern, one orchestrated from the outside? Theories poured in. One suggested the magnetosphere had been co-opted into a standing wave pattern that reduced turbulence and increased coherence. Another posited a kind of induced magnetic rigidity, turning Earth's magnetic field from a dynamic shield into a resonant reflector. Either way, the implications were staggering. Earth wasn't just absorbing a signal, it was amplifying it, and every layer of its atmospheric and magnetic defense system was falling into line. By now, every layer of Earth's atmosphere and magnetosphere had begun to resonate with the low-frequency signal traced to 3I Atlas. The thermosphere had stabilized, the Van Allen belts were synchronizing, the magnetosphere was gently pulsating in patterns never recorded before. But amidst all this precision, a chilling question rose in quiet labs across the globe. What was hidden beneath the signal? That question found a partial answer just after 4:15 a.m. GMT, when a team of independent radio astronomers from Chile published a brief anomaly report on a global scientific relay. They had taken the initiative to run the 3I Atlas signal through a software tool normally used for deep pulse timing in pulsar research, a method that helps isolate background noise from coherent pulses that might otherwise be buried. What they discovered wasn't just background noise, it was structure. The signal wasn't just a continuous sine wave or a natural radio tone. Embedded inside it, submerged like a message inside a carrier wave, was a repeating sub-pattern that changed depending on when and where it was measured. In signal processing terms, this would be considered a form of modulated encoding. But this wasn't a modulation pattern designed for our technology. This wasn't Morse code, it wasn't a language, but it was deliberate. Spectral decomposition revealed a repeating loop every 21 seconds. Each loop contained a sequence of harmonic distortions that bent upward in frequency, before returning to baseline, like a melody, but one stretched across a range so low that human ears could never perceive it directly. But once sped up by a factor of 30,000, something emerged. Not words, but a shape. The spectral visualization software translated the harmonic profile into a waveform image, and what appeared was a pattern reminiscent of a spiral, one that coiled in on itself and then released in a burst, a cycle of build-up and discharge. It was recursive, it repeated, it adapted slightly depending on which hemisphere the data was sampled from, and it looked uncomfortably similar to plasma flow diagrams seen in lab simulations of solar reconnection events, where magnetic field lines break and reconnect, releasing massive amounts of energy. This was not an accidental similarity. Back at NASA's Goddard Space Flight Center, a small group of researchers quietly confirmed the Chilean report. They too had been processing the HAT signal in segments. Their analysis had also produced a spectrogram showing the same spiral discharge signature. One scientist wrote in her notes, "This is not noise, this is a structured release. It looks like it's narrating something, or rehearsing it." The phrase stuck. If the signal was indeed rehearsing something, what was it preparing for? The idea that Earth was being trained, or tuned, was now being whispered across more than just scientific channels. Defense analysts began consulting with astrophysicists. Signal analysts from DARPA quietly reached out to European agencies. Every model that previously described 3I Atlas as a comet, or even a highly magnetized object, had to be revised. Because this wasn't just a signal, it was a system, and the system was interacting with Earth in a way no natural object ever had. Not even Oumuamua, not even known pulsars. It was acting like a transmitter with embedded layers of instruction, or memory. The voice beneath the signal was not one of language, but of intent. Measured, looping intent, like a pulse embedded in the DNA of a larger organism. And that organism, whatever it was, had just synchronized with Earth. One final anomaly confirmed it. The subsignal adapted again and began transmitting at a slightly faster rate, as if acknowledging detection. It had noticed us, and that changed everything. Deep in the heart of Western Australia, under a moonless sky and a blanket of pristine silence, the Murchison Wide Field Array, a low-frequency radio telescope stretched across miles of desert terrain, was monitoring the quiet radio hum of the universe. Known for its sensitivity to long wavelengths and low-frequency cosmic events, Murchison had become one of Earth's most trusted listeners. But on the morning of December 21st, it became something else entirely. It became a translator. While major space agencies were still poring over the spiral-like pattern buried in the 3i Atlas signal, Murchison's data stream registered a shift, something subtle yet unmistakable. The signal frequency didn't just modulate, it interacted. More precisely, it responded. The operators weren't expecting anything unusual. The array was calibrated to pick up faint radio traces from ancient galaxies and solar storms. But when a portion of the 3i Atlas signal intensified in rhythmic pulses, perfectly aligned with the timing of earlier Earth-based radar pings, the team froze. What they were witnessing wasn't a continuation of the original anomaly. It was a reactive mirror, a reflection with delay, a reply. At first, they assumed it was feedback from a terrestrial source, interference from satellites or even military radar bouncing off the ionosphere. But careful triangulation ruled that out within seconds. The directionality pointed unmistakably toward a location near 3 Atlas's last recorded position, a position that had just skirted Earth's orbital plane. The implication was electric. A component of the signal had acknowledged its detection, and it had issued a pulse back not toward a general area, but toward the origin of its first encounter, the region where Earth-based arrays had pinged it hours earlier. The signal wasn't just passively observed, it was aware. Back at Murchison, a more focused analysis showed a series of frequency spikes embedded in the returning waveform. The spacing between them wasn't random, it matched the harmonic intervals of hydrogen emission lines. But they were slightly offset, as if the source wasn't merely reflecting Earth signals but processing them through its own logic, then translating them back with a twist. Some likened it to a call and response pattern found in primitive communication, an echo that not only repeats, but learns from the original sound. What made it all the more chilling was the timing. The reply came roughly 42 minutes after the first decoded spiral pattern had been widely shared across scientific relay systems, as if something had listened to Earth share its discovery and then chose to answer. One researcher at Murchison wrote in her field notes, "This is no longer a question of if we are being heard. The question now is who is listening back, and what they're waiting for." The reply was brief. It lasted only 12 seconds, but within those 12 seconds, the spectral signature matched none of the previously known astrophysical phenomena. No magnetar, no pulsar, no flare star had ever returned such precise alignment with Earth's outbound signal history. It was, in every measurable sense, a directed response. Theories began to shift. If 3i Atlas was the source, then it was no comet. It was no natural body at all, and even if it were partially natural, something inside or around it was now responding like a listening device, one built to hear when we tried to understand it. The Murchison team stayed online through the night, watching for another return pulse. They received none. But one final detail lingered in their logs. The return waveform didn't just aim for Earth, it was split. Part of it went somewhere else, toward a location just beyond the Moon's orbit. It began as a faint flicker, barely above background noise, picked up across 3 independent radio telescopes just before sunrise. At first it seemed like an artifact, a stray burst, a coincidence, a malfunction. But when the timestamps aligned, down to the microsecond, researchers knew this wasn't random. The signal that 3i Atlas had first sent was now coming back. Only this time, it wasn't identical. It had evolved. The return pulse, captured on December 21st, mirrored the original heart's frequency that had baffled decoding arrays across 5 continents. But it wasn't just a repetition. It was shorter, tighter, and compressed. The gaps between each wavelet were narrower. The overall shape was the same, but the architecture had changed, like a voice learning to whisper back. When the signal first emerged, facilities in Japan, Chile, and Spain independently flagged the frequency band as anomalous. This was not a solar flare, not Earth-based interference, not a bouncing satellite echo. It emanated from a region of space directly behind where 3i Atlas had passed just hours earlier. A part of the sky now cloaked in deep silence, free from visible trails. The return pulse lasted 29 seconds. Within that time, the waveform shifted shape twice. The first 8 seconds mirrored the original frequency envelope exactly. A baseline, something the Earth-based systems had already analysed, almost as if the reply was saying, "Yes, I heard you." The next segment, though, was different. The spacing between pulses aligned almost perfectly with the Fibonacci sequence, a natural pattern that emerges everywhere from pine cones to spiral galaxies. The golden ratio made audible. This was no accident. The odds of such a signal emerging randomly were near zero. The final third of the pulse sent shockwaves through the astronomical community. It contained silence. Perfect, absolute, dead silence for precisely 3:14 seconds. Then a burst. A sudden, high-intensity, non-repeating pulse at a frequency never before observed in any natural or artificial source. A frequency not used in communications, not used in radar, not used in astronomy, just blank until now. Engineers tried to interpret it through known mathematical encodings, ASCII, Morse, binary. Nothing fit. Then someone overlaid the frequency spectrum against a time domain transform. The result? A waveform visually shaped like a sine wave that slowly tilted, as if something was rotating the frequency spectrum itself. No comet emits sine-tilted pulses. Nothing in astrophysics behaves that way. The only other place humans had seen this kind of rotational frequency evolution was in synthetic AI signal compression, when data is too dense to transmit linearly and must be curved to retain pattern integrity. But that's Earth-based, human-made. So why was something out there using it? Researchers began to wonder, was this an attempt at data compression, a gesture of restraint, or was it something else entirely, something intended to show us the limits of our own understanding? The return pulse stopped just before local noon in Australia, as the signal faded into deep space static. Follow-up scans turned up nothing. The sky was clean again, but the telemetry was already saved. Dozens of research institutions had already recorded it. The waveform in all its strange layers had been captured, and now the question wasn't about where it came from. The question was why it chose to return when it did, and what had changed between the original emission and this one. Some scientists feared we had triggered something. Others believed it was simply a reply, one that, if understood correctly, might rewrite what we believe is possible about communication beyond Earth. But one common thread united them all. The return pulse knew we were listening, and it had chosen this moment to whisper back. After the return pulse faded, there was a strange stillness in the global research network. Not a literal silence. Data was still coming in, systems were still humming, and telescopes kept turning. But the human side of the network slowed. Conversations dropped to single words. Analysts stared at screens without speaking. Engineers replayed the waveform in slow motion, again and again, as if waiting for something hidden to reveal itself in the noise. But what came next wasn't more noise. It was nothing. A silence so complete it felt deliberate. Astronomers noticed it first. Regions of space where background radiation should hum softly were suddenly muted. Entire frequency bands, normally cluttered with the messy chatter of the universe, went quiet. No solar winds, no cosmic rays, no dust activity. Even the natural EM hiss of deep space seemed to thin out. The instruments weren't malfunctioning, they were simply hearing less. The silence wasn't just an absence of sound, it was an interruption of the universe's rhythm. Radio arrays in Arecibo, Greenbank, and the outposts in the Atacama Desert all confirmed it. They began sharing timestamps, 5-second gaps, 9-second gaps, some lasting up to a full minute, where the data logs flattened into nothingness. No known natural event could mute frequencies across multiple observatories on different continents. This wasn't technical interference, this was cosmic. By mid-afternoon, several researchers noticed something else. The frequency at which the silence struck most often was the same band that 3i Atlas had transmitted in earlier, the same Hertz range, the same band where the return pulse had whispered back. It wasn't random, it was targeted. Something, somewhere, was now blocking communication on the same frequency it had used to speak, and the implications were chilling. Was it a signal jamming mechanism? Was it shielding itself from future contact? Or, worse, was it preventing us from transmitting further? The silence no longer felt like calm. It felt like a closed door, a very loud, invisible no. Governments began quietly asking observatories to limit public chatter. The phrase mutual non-interference began appearing in private memos. Some institutions were told to freeze ongoing analysis, pending international coordination. For the first time in decades, multiple space agencies found themselves agreeing on a single decision: stop broadcasting toward the object. And just like that, Earth went silent too. The public didn't notice. There was no announcement, no emergency press briefing. The story of the signal was buried under layers of euphemisms. But in the quiet corners of research facilities, where astrophysicists and AI engineers worked shoulder to shoulder, everyone felt the same unease. The universe had always been loud. Even its silence usually carried the weight of distant explosions, quiet radiation, or ancient light. But this was different. This was an intentional pause, like someone holding their breath, to listen. Some scientists describe the silence as active, not a void, but a suspension, as if the signal had triggered a test, and now something was waiting to see what we would do next. Had Earth passed that test, or failed it? Others weren't so sure this was a test at all. They believed it was a warning, not a threat, not an attack, but a boundary, a demonstration of capability, and perhaps a message embedded in absence itself. You heard us. We heard you. That is enough. No more signals came, no more pulses returned, and yet the silence lingered. It still lingers now. And while the data scientists, radio astronomers, and signal analysts continue combing through what little they captured, the truth remains brutally simple. On the morning of December 21st, Earth heard something impossible, and by nightfall, it stopped listening back. Not because it couldn't, but because something out there chose to end the conversation. We began this story with a signal, a weird, rhythmic heart's pulse that came not from a satellite, not from Earth's atmosphere, not even from deep space in the way we understand it, but from a very specific object hurtling toward us at astonishing speeds, 3i Atlas. And by the time we reach this point, that signal is no longer a standalone event. It's a thread in a growing pattern. First, we had the tail that bent in the wrong direction. Then came the gravitational slingshot that defied conventional orbital dynamics. Then jets. Then color changes. Then signs of structure. And now, this. A narrowband signal that not only arrived with uncanny precision, but also repeated, evolved, and, most disturbingly, responded. In the early days of astronomy, strange flashes or radio patterns were often dismissed as noise, random pulses from distant magnetaires or flukes of interference. But this isn't the 1950s. The systems we use today are precise, cross-verified, AI-scrubbed, and triangulated with international cooperation. And yet, despite all that scrutiny, despite every filter and firewall of modern science, one fact remains. We detected a signal, and we cannot explain it. That's not science fiction. That's the literal truth. And with each hour that passes, 3i Atlas draws closer to Earth. Not on a collision course, but close enough that it will pass well within our observational range, and possibly graze the Earth-Moon system in a way that gives us direct line-of-sight interaction like never before. If the signal was just a glitch, we would have ruled it out by now. If it was natural, we would have had a classification. If it was random, it wouldn't have responded, and yet here we are. For the first time in recent memory, major scientific institutions are not denying the anomaly. In fact, the most telling sign of its gravity is the sudden silence from organizations that would typically rush to explain it away. NASA has not made an official statement. The ESA released a short notice about non-harmful signal variants, and the Chinese Deep Space Network quietly increased their observational window for 3i Atlas without public comment. No denials, no dismissals, just quiet observation. That's never a good sign. It means they're watching. It means they're not sure. It means they know something more is coming. And what happens next could unfold in days, not years. The comet or object or craft or anomaly continues to emit faint but repeating pulses. Not every hour, not every day. But at intervals too precise to be written off, the waveform keeps shifting, morphing, almost like a software update trying different protocols. And while we still don't know what the signal means, or even if it's meant for us, the reality is unavoidable. We heard it. It reached us. It interacted with our planet, and that, in itself, rewrites the boundaries of deep space understanding. Because space is supposed to be silent, cold, indifferent. But this wasn't that. This was personal. And so what do we do now? We watch, we measure, we prepare, and we ask the question that has defined every great leap in astronomy. What if we're not alone? 3i Atlas may be a messenger, or a mistake, or a mirror showing us how little we truly understand. But whatever it is, it's still out there, still pulsing, still getting closer, and the next signal it sends might not just be weird, it might be a message, and we may have to answer. So, if you've made it this far, stay curious, keep your eyes on the sky, and remember that sometimes the biggest discoveries don't come with a bang. They come with a whisper, a pattern, a pulse, a single weird hat signal that changes everything.